6 a.m. marks the birth of the sun, and 6 p.m. its death. We are now at 10:36 a.m. Humans have only been around for less than a second, and we're reaping all the benefits of its warmth. But it won't always be like that. The sun's heat will slowly increase until it becomes too dangerous for human life. And even today, during the sun's golden age, it already brings many dangers that we are only beginning to understand. Using the latest optical imaging techniques to see what's happening on the surface of the sun, scientists are learning about sunspots, solar flares, and the hurricanes they release into space.
The sun's not alive, but sometimes it has the feeling as though it is because it looks angry.
March 10th, 1989. The sun ejects a giant cloud of charged particles. 3 days later, the solar storm hits the Earth. In Quebec, Canada, 6 million people are about to discover just how angry the sun can be. The sun's warmth and light sustains life on Earth. But it can also play havoc with our modern way of living. Our world depends more and more on technology. Our cities rely on complex networks of power lines, and our communications depend on sophisticated satellites. They can all be wiped out by the sun. Billions of tons of high-energy particles erupting from the sun send powerful storms hurtling through our solar system. Our growing realization of how devastating these storms can be makes the job of space weather forecasters like Larry Coombs ever more significant. At NOAA's Space Environment Center in Boulder, Colorado, they try to predict the sun's violent moods. 1989 brings one of the most dramatic space storms that Larry Coombs has ever seen.
The storms were an eye-opening event for understanding what can happen when the sun has its violent moments.
March 10th, and a telescope in New Mexico captures this solar flare exploding. It sends an electrically charged hurricane toward Earth at a speed of more than 1 million miles an hour. 3 days later, it causes a huge electromagnetic storm over the northern hemisphere. At 2:44 in the morning, Quebec in Canada feels the full force. More than 1 million amps of electrical current overwhelm the power grid. Within seconds, power stations across the province go down like dominoes. 6 million people in Quebec are left without electricity. The blackout lasts for 9 hours. The only light in the sky that night is an unusual pink glow caused by the storm. The events in Quebec cause hundreds of millions of dollars in damages and loss of revenue. Now, the team at Boulder are on Sunwatch. Using live, up-to-the-minute satellite images, operating 24/7, they keep an eye out for any sudden changes in the sun's behavior that can cause disruptions, like in Quebec.
We look at sunspots, and these are these dark, gnarly-looking areas, and this is probably about the size of 14 Earths. We also look at prominences, which is this thing that's sticking out on the side of the sun. Both of these areas can create solar storms.
But how? Scientists believe that the sun's moods are determined by its complex magnetic fields. New magnetic fields are constantly being created because rivers of hot hydrogen gas, called plasma, which are electrically charged, flow at different speeds around the sun. The sun's rotation tangles these magnetic lines together, forcing parts of them to emerge on the surface as dark sunspots, and prominences that start sticking out from the surface. The plasma flows and field lines continue to build up as under this sunspot. Eventually, the field lines get so twisted, they snap like rubber bands and cause explosions. So once prominences and sunspots are seen, forecasters are on alert for explosions on the surface of the sun. Sunspots can be followed by solar flares. These are so powerful that they are like millions of megaton nuclear bombs all exploding at once, sending electrically charged radioactive particles out into space. prominences just get bigger and bigger. Some end up looking like flares before they too blow up. Both flares and prominences can also be followed by even bigger eruptions in the form of what scientists call coronal mass ejections, or CMEs. When these occur, the sun discharges billions of tons of electrically charged gas. All these phenomena unleash high-energy particles, which carry electromagnetic fields with them to Earth, and they can disrupt equipment that is electrically conductive, such as a power line. Normally, solar wind carries about 1 million tons of electrically charged gas particles away from the sun every second. But when these explosions occur, the storm clouds of additional particles are more dangerous. The Earth's magnetic field, or magnetosphere, which protects us from solar wind, is overwhelmed. Usually, it deflects the particles toward its weakest point, the poles. Here, they react with oxygen and nitrogen in the atmosphere to create streams of different colors, a phenomenon known as the aurora, or northern and southern lights. But when strange lights appear in the sky away from the poles, as in Quebec, they are a sign of intense solar storms breaching the magnetosphere. Boulder, Colorado, September 6, 2005. Larry Coombs and his colleagues monitor an intense solar storm.
As we're speaking right now, we're having a strong solar flare going on. If we look at the blue image, we can definitely see the energy being blown out from the sun at millions of miles per hour.
The sun experiences one of its violent moods, producing explosion after explosion after explosion. Northern lights appear all over America. This time, it's not the power grid that's affected, but communications.
High-frequency communications, radio blackouts are occurring with our aircraft. We're also having problems with satellite phones as well. If we look at our plots up here today, we can see that this activity is affecting the Atlantic and the Pacific. So both ways, communications are blacked out.
We've got 12 in progress.
Everyone wants an update, and the alert status is high, particularly for any airlines that fly near the poles, where the only communication is via high-frequency radio. During solar storms, high-frequency communications can be wiped out, blinding the pilot and risking the lives of passengers.
Great, thank you.
But if airlines get warned, they'll reroute or even ground planes. And it's not just the airlines that fear radio blackouts. Other communication systems can be knocked out. In space, satellites have been damaged, causing loss of signals. Imagine no TV. Imagine all cell phones stop working. But it's not just electrical damage and radio blackouts that these storms can cause. They can also increase the risk of radiation. Solar storm radiation is potentially dangerous for passengers on airplanes. But this radiation poses even greater dangers for astronauts out in space. Late October 2003. 3 huge sunspots appear on the sun's surface, one the size of planet Jupiter. A giant solar flare erupts from the surface of the sun, pointing straight toward Earth. And high above the ground, astronauts on board the International Space Station find themselves directly in the path of the deadly radiation the sun unleashed. Scientists know that the sun was born over 4.5 billion years ago. That's dawn on our sundial. It's now 10:36, and scientists have only learned about solar radiation in less than the last second. We all experience one form of solar radiation. It's sunshine, made up of ultraviolet light. Too much sunshine can cause sunburn and skin cancer. But the ozone layer protects us by blocking out the most harmful effects of UV radiation, and sunblock can do the rest. But there's one place where the type of solar radiation is much harder to protect against. Space. Space travel has always been dangerous. But when astronauts first ventured beyond the Earth's atmosphere,